Scott and Lisa are here to talk about North Carolina and freight flows. So Scott Boone works in the Austin office, and he does visualization, data analysis, and mapping, and across a whole bunch of transportation disciplines, from environmental to freight to transit. And then Lisa Destro is senior associate, and you've been thinking about freight for a long time and been working on development of a whole bunch of state freight plans over the last decade and rail plans, dealing with truck parking studies, market analyses, and of course doing a lot of, I guess you call it CBAs, cost benefit analysis, for a whole bunch of folks looking to get grants there. So I will turn it over to you guys.
All right. Thanks, Ed. Good morning, everybody. Thanks for joining us. So Scott and I are going to be talking about the tool we developed for North Carolina Department of Transportation to visualize freight demand in the state. So I'll be starting it off with providing some background on why we did the tool and the processing of the data, what were the data sources that we used, and then Scott will be actually showing the visualization elements of it and giving you a demo. So this was developed as part of the statewide multimodal freight plan, which is a FASTAC requirement, and the plan was completed at the end of 2017. It was the first time that NCDOT did a multimodal freight plan that established specific goals for freight transportation in the state, strategies and actions to contribute to job growth, economic competitiveness, and quality of life of the industries and residents of the state. So this was kind of the key components of the overall approach to develop the plan, and the freight flow tool was part of the demand estimation. So basically what we did was we took a look at what was the economic structure of the state in terms of what were the key freight-intensive industries that were driving freight demand in the state, what were their industry logistics patterns, so how are these industries using the freight network, what were their needs, bottlenecks, et cetera, and then what was the priority infrastructure for them. So we identified what we call the priority freight network in the state. And so the demand of the traffic flows for both existing and future conditions were just one element to be able, under kind of the umbrella of developing those goals, strategies and actions for the state freight planning. So the freight flow visualization tool was an interactive way of showing pretty dense data that is useful in terms of determining what trends are affecting freight demand in the state, what are the industries that are projected to grow over the next 30 years or projected to decline, and doing that in like dynamic fact sheets. So typically what we had done before is kind of pretty boring tech memos where you have lots of tables and charts and different ways of presenting the same data to highlight, what are the key trading partners, what are the key commodities, what's the modal split, so on and so forth. So this was just kind of a neat way of showing that same data where the user can filter and take a deeper dive into the data and look at it in a more visual way. And it was especially useful to be able to show the data not only at the state level, but at the county level as well. And it was especially useful to support the metropolitan planning organizations and rural planning organizations' own local planning efforts, where sometimes they didn't have the staff or the resources to do their own commodity flow analysis for those specific counties that were in their regions. And then, like I mentioned before, just to augment kind of the outreach process during the state freight plan development, to get to the point communication, develop some cool infographics and interactive tools for stakeholders and elected officials as they were reviewing the plan and taking a look at the initial results. So it's also a good way to get input on the processing of the data from the local MPOs and RPOs and vetting the data. So the The commodity flow data provides insight into the origins and destinations, what modes are being used, the commodities that are being transported, directional flows, as well as current and forecasted conditions. And then the key data sources that were used are the publicly available Federal Highway Administration's Freight Analysis Framework data, which is the FAF data. And the FAF data comes at what they call the FAV zones, which are pretty aggregate zones for the US. They include the major metropolitan areas, and then, for example, some rural states are just one zone in the data set. So this was disaggregated to the county level so we could take a deeper dive in the state and take a look at freight demand at the county level. And then for rail, we use the Surface Transportation Board's rail carload waybill sample for North Carolina, and we forecasted that out to 2045. Oh, sorry. So this is just to show you what, the freight flow disaggregation. There's a lot of different data sources that we use to vet the data, a lot of processing of the data to make sure that it was all kind of harmonized in the same language. Different data sources have different, for example, not just geographic regions, but also commodity codes, units. Some might not be forecasted. So there's a lot of processing of the data to make sure that when we implemented the visualization, you can add everything all up, and it made sense.
Yeah, so for me on the visualization side, this tool provided an opportunity. I think this work actually took place in 2016, early 2017. So it's been a few years, and so this was really one of the first chances we had to start using tools like Tableau, which really kind of were an advance on the, earlier we might have used a mail merge or something to make 100 different fact sheets for 100 different counties in North Carolina. This provided an opportunity to, one, provide, as Lisa said, a more dynamic approach to reviewing the data. Two, give us a way to integrate the data exploration and the product development to help the client, really start to understand the data at a base level before we had any kind of final deliverable, which was a really valuable workflow and enabled us to add additional data as it became available actually during the process. We found that, as opposed to other more rigorously developed web-based tools, Tableau, enables us to essentially get a concept to put in front of the client in basically a day's worth of work and really, provide something useful and deliverable with about a month's worth of analyst time, which is an order of magnitude cheaper than developing, early types of web-based interactive tools. So this was a really great chance to put that into play. We also used a very simple Microsoft Access backend database. Both of these are really portable, easy to share development among multiple analysts and with the client. And so it did provide a pretty trim package for the development of visualizations. Of course, there were some cons. At this point, we did not have a server license, and neither did really any clients, and so they had some limits on how much we could distribute proprietary data, and making sure that aggregation took place to keep that limited. Tableau is very good at doing some things very easily and also just makes other things impossible. It can be very inflexible, and so being able to communicate what the limits are of that development were important to find out. This was a very high database size set. We kept bumping our heads on the ceilings of both Tableau and Access at the time. And we also encountered something of an end user learning curve, and so we actually had to develop pretty comprehensive documentation to enable its use among the different clients, especially taking out to the public meetings. Of course, we always have the idea that our data visualizations are self-curating, and you look at it and you get it within 5 seconds, but in reality, finding something that has the flexibility to communicate rather complex combinations of filters and stuff actually kind of takes some external curation. So I've seen a lot of folks in this conference talking about breadcrumbs and stuff, and those are all great best practices that have emerged over time. So instead of looking at these static versions, I'm just going to pull up the tool itself and just kind of click through it. This is the profile at the state level. This was, I think, one of our efforts to make it look a little bit more pretty and infographic-y. But essentially what you can see down the left-hand side are the different commodity codes Those are aggregated up, I think, from closer to 25 or 30 different codes, but in the interest of limiting, everything you add, you get multiplied with a number of other attributes. And so limiting to the top 10 or 12 enabled us to keep kind of everything on one page. And of course, we've got kind of the hover over here showing the raw numbers, and we've got different units. We can show it both by weight and by year, and then also switching over to value, of course, changes over to the balance a little bit more. You can see it's a lot more manufactured goods as opposed to raw aggregates. And then down here in the little donut charts, we've got mode and the flow direction, whether it's inbound or outbound, whether it stays within the state or just flows through the state. And of course, clicking on any one of these will get you a little bit more detail in the cross filtering. So if we click on air, you can see that there's a lot more machinery, electric, and precision instruments. And then if we wanted to look at most of our exports, you can see what the highest North Carolina exports are in terms of weight, in terms of dollars. So kind of all, kind of classic cross-filter use cases for a Tableau. The county profiles were the original impetus for this work. The counties, I believe, had requested fact sheets. And so taking that same approach, just being able to have a single image that is about what you would expect on an 8.5 by 11 sheet of paper, showing the top imports and exports, where those are going. Of course, all these are cross-filterable in the same way. Like some of the other visualizations we saw earlier, really important to keep that top of the line number up here to make sure that you know what your universe of in this case, freight flows contains. And we also included the same data for national trading partners, this way looking at the states to and from North Carolina. This is one of the areas where it starts to get tricky when you're showing multiple places on a map. Of course, this is data that's inherently origin and destination, right? It's not based on either one state or the other state. It's actually the trip. In the time since we made this, Tableau has actually started to include some features like on-the-fly desire line generation, which is pretty useful. But in this case, we ended up just doubling up this data set and then making, subtracting out the relevant stuff, so we didn't double count, but being able to show both what's going in and coming out of North Carolina. And so by filtering on that, we can look at that in a little more detail and split those up by direction. Again, commodity types here, the mode through which it moves. Another nice thing about this data set is actually included international data as well. So in a multi-leg trip where you might have something come in from some region around the world, one of the, I think, 7 or 8 regions around here, we can also drill down and look at what those look like on a global scale. Again, using those same breakdown numbers as you see along the left-hand side. So this was it was a fun tool, and I think to develop. I think it ended up being pretty useful for the clients in a way that they could see. Again, being able to filter by multiple attributes really revealed a lot of things that they had not been able to see the data before. Would have taken a lot of dedicated effort. And this way, we could provide a kind of a one-stop shop. And the tool ended up being pretty easy to update. I think at one point we actually wanted to add a whole other data year, and it was a pretty minimal effort to include that. And so presumably, if they wanted to update it again, that would be something that would be pretty easy to implement. Again, this was an early version of Tableau, and I think there's a lot of new features that would be fun to implement here, but certainly a great base product. So that's really what I have. We have some kind of conclusion things, but I think we've all seen pretty similar presentations. So I think maybe just opening up for questions is probably the most graceful.
All right, questions for Scott and Lisa? Wow, everybody.
It's lunchtime.
Well, could you talk a little bit about data suppression? So you mentioned that you had some confidential data in there. How do you deal with that in the visualization?
Yeah, so this was all put on Tableau public. So we had to make sure that it was aggregated to the degree that was acceptable to present. I think a lot of the main issue for a lot of the FAF data is for some really small counties, especially when you're disaggregating, you might only have one producer of aggregates in, Buncombe County, North Carolina. And so, identifying those areas where we fell below the minimum threshold to put it in separately. So we would have to aggregate it at that level and make sure, well, that's a tough word, sorry, awkward. We would have to aggregate, maybe an example would be petroleum instead of aggregates. That's confusing to say. To make sure that we weren't revealing any proprietary trade information. And so just making sure that we communicated with the client like what that level of importance was.
Yeah, that was especially the service transformation with the label. You have the confidential use file, so we couldn't, in the county profiles, I believe when you select rail car loader or owner model, you don't show the commodity breakdown, just because we wanted to